Okay, so we're actually going to start with just a couple exercises. I often compare learning to code to learning a musical instrument, whereas even if you understand it intellectually, it just still takes a ton of practice. It really does. It's a totally new way of thinking, and the more you practice, the better you get at it. So we're going to start with just two exercises that review some of the concepts from yesterday. So I'll give you a minute just to pull up Slack, because I'm going to send you the exercises through there in the general channel. So there it is. Completely random names, no references to anything. So the exercise is to fill in the comments below and keep track of what values, I'm just reading from here, what values Mario and Luigi have on each line. So just fill the comments and keep track of them. And actually, if you can save it and then share the link directly with me in Slack, that'd be fantastic. Right.
Why wouldn't it run? Comments.
I
mean, well, I added a print statement and it still doesn't. Oh, print is P.
It works for me. I'd have to look at it. Oh, you got it now? Yeah. Okay. Okay, so someone could help me walk through this. What happens on line 3? What is Mario? I'm sorry. Yes, line 3. Yes, you're right. I meant line 5. What happens on line 5? What's Mario? Mario is 2. And Luigi stays at 2. Cool. And again, the golden rule here is that everything to the right hand of the equal sign processes first, then we assign it to the name that's on the left-hand side of the equal sign. That is just simply the order in which Ruby processes it. It's arbitrary. Whoever developed Ruby could have switched that if they wanted to, but it's just they decided, no, left is where the name goes, and right is the values that gets processed first. Awesome. On line 6, what do we got? Mario is 2 and Luigi is 4. Looks good to me. How about line 7? Mario is 1, Luigi is 4. Line 8, Mario is 1, Luigi is 2. Mario on line 9 is 1. Luigi is 2. And on line 10, Mario is Luigi is 2. Okay, yeah. I mean, if we really wanted to check ourselves, we could put a P statement after any particular line. So we can say, let's say after line 8, P Mario, P Luigi, to see if our line 8 is correct. And if we run it, we get 1 and 2, which is what we predicted. Again, ignore the green things. Any questions about this? Yeah.
So, what if you didn't put something and it didn't change? Like, I just put like the number 8. I just put Luigi is now 2. I didn't put what Mario was. Mario didn't change.
Mm-hmm. So what's your question exactly?
You put both names back each line.
Yeah, because the exercise is asking you just, and on each line, tell me what each name, each variable is at that time.
Right, but I guess when something didn't change, I didn't put it. But you got what you're saying.
Yeah, that's okay. I mean, yeah. You're saying because it's obvious that the other variable didn't change at that line. Yeah. Okay. That's fair. Okay. Awesome. One more exercise before we jump into the next concept. And this is a piece of code that is buggy. You'll see when you run it, it doesn't work. So your goal is to fix this code. However, only fix it by changing the order of the lines. So don't change any of the content, but just switch around the order of the lines until the code runs without any errors. Does that make sense? Actually, I take that back. There's one change you're going to have to make to the content itself. You can Slack this to me as well. Lisa, if you want to check.
Hey Jake,
Yeah.
can you repeat the instructions? I want to make sure I didn't.
Yeah. So the instructions are to fix this code. Right now when I run it, I get an error. So fix the code so you don't get any more errors when you run it. Mostly what you're going to do is just rearrange the order of these lines of code. However, there's one change to the text that you'll have to make as well.
So we're not adding new variables.
No, you're just changing the order of these existing lines. Okay, so let's take a look at this. So when I first run the code, I get this error message. Oh, man. What line is broken? 2. How do you know? It says 2. That's how you know it's broken. I could have told you that 2 is broken, again, even if I didn't see the code. Just the error message. Okay, what's wrong with 2? Yeah?
You have to define breakup.
Yeah, I have not. Well, but what does this error message tell me is wrong? That is true. But what does the error message say is wrong?
Erie.
It says Erie is wrong. So, Crystal, you're right. There's two things wrong with that line, but the error is just pointing out Erie. Why is it pointing Erie and not Franklin? Because it's first. Yeah. As soon as I fix that, trust me, it'll point out Franklin too. But it's stopping at the first roadblock. Okay, so in theory, we can fix that by moving this definition of the Erie variable above that line. And now let's run the code again. So now we got the Franklin problem. This time it's on line 3 because that line of code moved. How do I fix that? So I can move line 7. That's where we define Franklin and make sure that that exists above where we refer to Franklin on line 4. Now you run the code again. What line of code is problematic? 3. Because it says 3. What's wrong with 3?
Grand, we don't know what grand is.
It says do not know what grand is. So it mentions grand here on line 3. How do we fix that?
Put grand up.
Yeah, well, yeah, line 7. My first gut reaction was, oh, we define grand here. I can move that above. If I try that, let me go back to the Franklin problem. So I'm going to move this definition of grand up above. Now, which line is problematic? 7. What's wrong with 7?
Grand.
Yeah. So I just fix that. And then I run the code and ignore the green thing. But the fact that we got the green thing means that we're good. Any questions about that? Okay. Later today, I think we'll get to it today, you're going to see how a simple switch in the order of 2 lines of code caused one of the businesses that I worked at as a developer to lose a ton of money just by having 2 lines out of order. You're going to have that as one of your exercises. So the order really matters. Okay, we are on to the next concept. So yesterday we talked a ton about code flow, how the computer processes each line top down. We talked a ton about variables, and we temporarily saved the US from an imminent threat from Kazakhstan. Today we are going to talk about a new concept called conditionals. And this is going to throw a monkey wrench in everything we know, because I've stressed all yesterday how the computer only processes things top down, 1 line at a time. And we're now going to see that there are some exceptions to that rule. So let me pull up a new example here. And let me run it. Let me do this so ignore the green things. Okay. When I run this file, nothing happens. Let's break this down line by line. On line 1, we create a variable called Rupert, and we make that 7. On line 2, we have a conditional. Basically, it's if this, then that. So if Rupert is greater than 10, then let's print Rupert, which is 7, to the terminal. And then we have this end thing. And I'll come back to that. So this, in English, is saying if Rupert is greater than 10, then let's print it to the terminal. Is Rupert greater than 10? It's not. It's 7. So the way the computer processes this is that it actually skips line 3. It skips over it. So we know that the computer could go top down, but I never told you that the computer could sometimes skip a line. This is the first time we're encountering something like that. So the computer processes it line 1. It says, okay, I got it in my head. Rupert is now the nickname for 7. That's our variable. Then it processes line 2, and it says if Rupert is greater than 10, it's not greater than 10, so the computer actually doesn't even read line 3. It skips over it. how does the computer know how far to skip? It looks for an end. Every if statement has to end with an end. That tells Ruby that our if statement, our conditional, is done.
What's the biggest difference, though? And I know you used to have n there, but I noticed when you tab, it's all capitals.
When I tab,
If you tab inside here and type n, there's capital one. What is the difference between that and a regular one?
like this,
Yeah. No,
or all caps,
Yeah. Is there a difference in?
I don't think Ruby accepts all capital. I don't know why it's doing that autocorrect or that autofill. I've never seen an end in all caps. It should be lowercase. This, again, when we say that Ruby skips that line altogether, as you know, 10 divided by 0 should give us a non-division error, right? But we don't get an error. Why? Because Ruby skipped that line. It skipped it entirely. So that's the key thing to understand here. Okay, now if I switch this to if Rupert is less than 10, then print Rupert, then it does print it. In this case, Ruby ended up processing each of the 4 lines. It did line 1, it established our variable. Line 2 is Rupert less than 10, it is. So since that condition is true, Ruby moves on to line 3 and executes that line of code. And it prints Rupert to the terminal, and then we're done. Any question about this? This is the foundation for many coding concepts, but especially for something like artificial intelligence, right, where the computer has to make a decision based on various circumstances. If this circumstance is true, imagine making a self-driving car, right? If there is a truck ahead of us, we better slow down. If there's empty road ahead of us, then we can go up to the speed limit, right? That's the artificial intelligence is totally predicated upon conditionals. Yeah.
So the condition is if Rupert is less than 10. That's the condition.
Yeah. So when I refer to the condition, that's exactly right. It's is Rupert less than 10? That's the condition. If that condition is true, then we do whatever is between the if and the end. Yep. Okay. Let me pull up a slightly more complex example. Okay, so here we track a variable called Emily. Basically what we're going to do here is let's run it, see what happens. We get to, let me eliminate the green things again. We get to, let's follow the logic here. Let's see how does Ruby processing this. And I'm going to actually use the comments to help indicate which lines Ruby processes and which lines it skips as follows. So line 1, Emily is 100. We're establishing a new variable called Emily. It's a nickname for 500. So Ruby processes that line. So to indicate that, I'm going to put that little pound sign at the end to say Ruby hit that line and executed that line. Cool? We move on. Line 3, Ruby processes that line because it has to check to see if that condition is true. If Emily is less than 100, Emily is not less than 100, so it skips line 4. So I'm not going to put a pound sign on line 4 because Ruby never hits it, processes it. So far, does this make sense? Okay. If Emily is greater than 5, so Ruby processes this line. I think I'm just going to add pound signs here too. There's not much to process on the blank lines, but to emphasize that line 4, there's a gap there, that means Ruby skipped it. Okay, if Emily is greater than 5, is Emily greater than 5? It is. So we process line 8, and we print 2 to the terminal, which is why we see the 2 over there. So so the computer hits that line. It processes line 9, which concludes that conditional. If Emily is less than 1,000, is Emily less than 1,000? It is, because Emily is 500. So So it processes that line. That means we'll process the next line, line 12. And here we're overriding Emily. Right? Emily is no longer 500 going forward. Emily, henceforth, is 77. So we'll keep that in our heads. Or maybe I'll put it down. Emily is 77. Okay. We process line 14, which is blank. If Emily is greater than 100, we process that line. Do we process line 16? We do not. We skip over it because Emily is now 77, so it's not greater than 100 anymore. Whoops. So we skip over 16. On line 17, we conclude the conditional. Process line 18. If Emily is greater than 500, is Emily greater than 500? It is not. So we skip over line 20, which would have printed 3 to the terminal. This is why you don't see 3 in the terminal, because we skipped that line. And we're done. So Ruby processed everything one line at a time, top down. However, it skipped a few lines based on the conditions. Any questions about this example? Yeah?
Sorry, so if you do run that, it puts those numbers in a row?
If I run this,
Yeah.
it prints 2.
Why does it only?
Because the only line that I had that printed something with the P
Yeah.
that actually got hit was line 8. So I had a few other lines where I tried to print something. Line 4, I used the P to print something, and on line 20, I tried to print something with the P, but those lines get skipped. So the only line that has a P in it that actually got hit was line 8, which prints 2 to the terminal. Does that make sense? Yeah, good question. You know, on line 12, even though I'm establishing a new variable, I never told the computer to print anything. So it's only the 2 that gets printed. Okay, any other questions? This is your time to ask because you're about to get an exercise that's very similar to this. Okay. So in the following exercise, do exactly what I just did. Go through each line and then put a pound sign to indicate which lines Ruby actually executes and leave out a pound sign if Ruby skips it. So let me slack this to you. You should see it in general now. And then go ahead and save it and slack it directly to me when you're done. You don't have to slack it to the general channel. You can slack it directly to me. Of course, I had to make it trickier in my example. Okay, so let's walk through this. Okay, so I'm going to just mention a line, and you tell me if Ruby processes it. Line 1.
Process.
Line 2. Line 3.
Yes.
Line 4.
No.
Well, line 4 itself, Ruby does process, because it has to check that conditional. But line 5 is no. That's, yeah. Because Robert is not greater than Helen, it is less than Helen. Line 6, it does process because it concludes that conditional. Line 7, okay, line 8, yes. Line 9, because Helen, it says if Helen is less than Robert, but Helen is actually greater than Robert, so it skips line 9. Great. Line 10, line 11, line 12. How about line 13? Yeah, so Helen is greater than Robert, so the condition, or the code within that conditional does execute. But now we have a change to one of our variables, so Robert is now 140, what is it? 143, thank you. Okay, Robert is 143. And Helen is what? 77. Okay, good. You don't have to put that down. I just want to keep track. Okay, line 15 is blank. Line 16, yes or no? Yes. Line 17, yes, because Helen is less than Robert at this point. So line 17 process, 18 process. So all in all, Ruby skipped just 2 lines out of these 18 lines of code. Yeah.
So if the lesbian is not true, it's the next line that it skips, not the line of.
Exactly. Because Ruby has to read that line to evaluate, is this true or not true? It has to read that. If it's not true, then it skips the line between, whatever code is between the if and the end. Yeah?
Just is like, so the lines like 7, 11, 15, are those, do we keep those blank just to make it easier to read? Or
Oh, good. So the question is, why did I put,
does the blank line serve a purpose?
yeah, why did I put new lines in there? And the answer is yes, I made it easier to read.
Okay.
And that is best practice when coding for real. Again, this code is not realistic code,
Sure.
but at least part of it is the fact that there's blank lines in there to make it more readable. That's exactly why I did it. Yep. Yeah.
When you say that those blank lines are processed, does that mean if you have more blank lines, it will actually take longer to run?
Yeah, good question. So the question is, if I have a bunch of blank lines, does Ruby have to actually go through each line? Does that take up some time? The answer is I'm not 100% sure. If it does take time, it's negligible. But I'm not sure. I know that when it comes to like JavaScript, you can do something to your JavaScript code called minification, which actually takes all your code. It does a lot of things to your code, but one of the things it does is it strips out all new lines and all spaces even. If you look at, here I can actually show you this. So here is there's a JavaScript library called jQuery. When I say library, it's just a lot of JavaScript that someone else wrote. So you can download a compressed version of jQuery, and you can also download an uncompressed version. So when I call minification, that's the same thing as compression. So let's look at the uncompressed version, and let me. So this is just a lot of lines of jQuery, right? And actually, if you want to just check how many lines it is, it's over 10,000 lines of JavaScript. That is the jQuery library. And if we want to use jQuery, it makes some JavaScript development easier. But let's take a look at the compressed version and sort of see what that looks like. That is the compressed version, which is the equivalent of what we saw before, except that it takes 4 lines. It looks like more, but some of these lines are so long that they're wrapping around. Now this is impossible to read, but that's fine. You basically, programmers don't write this. They write the original JavaScript, and then they run a program that compresses it to this. And this way, when the browser executes it, it's shorter because there's less code there. So I guess that would sort of imply that spaces do matter to some degree. Yeah, you can't read it. Don't even try. Yeah, so that's a great question. I feel like there was another hand. Is there another question? No? Okay. Great. Now, I would like to show you how you can actually put multiple lines of code within your conditional. All our examples until now only had 1 line, but let's do a new example. So let's look at this carefully. We have 6 lines of code here. On line 1, we establish a variable called Rupert, which is 7. We then say on line 2, if Rupert is less than 10. Is Rupert less than 10? It is. So we now process the following 3 lines, top down. We will print Rupert to the screen. So what's it going to print? 7. We then override Rupert and say Rupert now is a nickname for 5 instead. On line 5, we say P Rupert, what's that going to do? It's going to print what to the screen? 5, and then we end. So if we run this, we could see our prediction was correct, and it prints out 7 and 5 to the terminal. So there's nothing to stop us from putting tons and tons of lines of code within our conditionals. Nothing really new here. It's just something you've never seen before, at least in this class. Any questions about that? Yeah?
So, is there a reason why you would want to do this instead of just putting the end output equals Rupert and then Rupert equals 5 and Rupert and run the same?
So where should I put the end? On which line?
Right after line 3. So
Here?
yeah.
Yeah, the code will run the same. In fact, the code will run the same without a conditional altogether. It just, because that condition happens to be true. So again, all these examples are highly contrived at this point.
Okay.
So yeah, if my goal was just to print 7 and 5 to the terminal, I would just do this, really, you know. So it's really to demonstrate conditionals. We will get to examples that we'll see why this is why it's necessary to have these concepts. Yeah, but you're right. That was a good question. Any other questions? Okay. Okay, I already demoed. Yeah. Okay. What happens if I don't put the end there? What do you think will, just not that you know, but guess. What do you think might happen?
Error.
It's a pretty good guess. Let's see. We get an error. This is an error you're going to see so many times. But you don't have to tear your hair out if you understand what it is. So here we have, now this is interesting. This is a little tricky. Because what line does it tell us is problematic? It tells us line 5 is problematic. And this is one of the few exceptions where, well, let's get to the next part first. So what does it say? Syntax error, unexpected end of input, expecting keyword end. That is a very long-winded way to say you're missing an end. You're missing an end. Now, why does it say that our problem is on line 5? The way I understand it is that it's basically saying, hey, I got to the end of line 5. I don't see any more code. I want to see an end. I don't see it. So it's sort of, when Ruby wants to see something and doesn't see it, it's hard to express what line is problematic, because it's not really a line of code that's problematic. It's what is absent from your code, which is problematic. And since Ruby has to put down some line number, it puts down the last number that it executed and wants to see an end but doesn't see it. Does that make sense? So this is, in 99% of cases, the line number is more useful. This is one of those cases of where the line number might throw you off a little bit, but at least you know what to look for. When it says expecting keyword end, the light bulb should immediately go off in your mind saying, okay, I am missing an end somewhere in my code. It is very common to forget to put an end in your code where it should be. So this, like I said, is an error message that you'll see a lot of. Yeah?
So is end normally required just in general, or is it specific?
End is specific to, this is the first time we didn't need end yesterday at all,
Right.
but for conditionals, every conditional needs to end with an end. We'll see other concepts that also need an end, but this is the first, conditionals is the first concept that we've encountered in this class that needs an end. Does that answer?
Yes.
Yeah. Great question. Other questions? Yeah.
Also, a conditional is when you put that less than sign.
Yeah, so really, I sort of refer to this whole structure as a conditional, but really it's the concept of that I have like an if. When I say if, I'm saying there's a condition. If this condition is true, then do something. Any other questions?
Could the conditional be if Rupert equal 10?
Ah, you might think that I paid Michael to segue me into the next concept. So, what if, that's the very next thing. Okay, awesome, thank you. Any other questions before we get to that, though? Okay, Michael's question is awesome. We were checking if Rupert is less than 10 or greater than 10. What if I wanted to check if it is equal to 10? So, what would you guess I would do for that? If you just took a random stab in the dark. Yeah?
This is just based off the syntax I saw for a different language a while back, but I think you'd use 2 equal signs instead of just 1.
Yeah, so Shane is right. We actually use 2 equals, use a double equal sign. And this code doesn't run because Rupert is not equal to 10, but let's change Rupert to 10. Now it runs. Can anyone, that's a tricky question, can anyone guess why we're using a double equals as opposed to single equals?
We use single with variables to define the variable.
Yeah, I think I'm hearing a bunch of people once. If some of you may be saying the same thing. Yeah, but I definitely heard some of you say this. The single equal sign is already used up for the concept of setting a variable. So on line 1, we can see an example of that. Rupert equals 10. A single equals is a way to create a variable. But to check for equality, to check in a condition, to see if something equals something else, for that we use double equals. It's a little weird.
So what happens if you just use 1 equal?
Good question. If you happen to use 1 equals, our code might still run as intended, but there's unintended consequences. So, yeah, it will still work. No, but we get this warning. I'm just thinking if I want to answer this question now. Let me just check something. See if my answer is correct. I'm going to decline to answer that right now because it's complex. So it is the wrong way to write it. You see we get this warning, but it's complicated for right now, but it's a good question. You know it's a good question if I decline to answer it. That means it's very advanced, or more advanced than I want to get to right now, but it's a really good question. It doesn't do what you think it does. It's not like an alternative way. It does something totally different, and the fact that your code still runs the way you thought it might is purely coincidental. You're lucky.
So it's still making the assignment of value 10 to Rupert.
Yeah, it does.
That statement is evaluated true.
Yes,
it's not wrong.
that is correct. But it's not what you thought.
Right.
Yeah.
Is there a triple equal?
There is a triple equals in Ruby, and it's a very nuanced difference between triple equals and double equals that doesn't really come up in real life. So double equals is the standard. In JavaScript, by contrast, triple equals is always what you use. But yeah, there is such a thing. Yeah, these are really good questions. Any other question? Okay. I have an exercise for you coming your way in general. In the general channel, that is. And this exercise is to keep track of each variable in the comments. Here I actually did you a favor and I already filled in, but I left you the question marks to replace with actual numbers. So again here, it uses concepts that you know, just a tricky example. So just fill in the question, replace the question marks with the proper numbers. And when you're done, you can go ahead and Slack your result to me. Okay, let's look at what's going on here. There's a certain tedium to keeping track of all these lines, right? This is, the good news is if you can like do this, then you can handle much more typical coding situations, which aren't necessarily this complicated. So this is taking you to the extreme so that you can easily handle some of the real world stuff. Although some real world examples could get pretty complex as well. So, okay, we have our 4 colors, purple, indigo, gold, and silver. Okay, line 8. If purple is greater than silver, is purple greater than silver?
No.
It is not. So basically everything that we have here remains the same as of line 9, correct? Okay. If indigo is less than purple, is indigo less than purple? It is. So that means we execute all these 3 lines of code. So gold equals silver. Oh man. Okay, so purple is 10. Indigo is 4. And we're not touching silver yet, so silver is still 77. What is gold now?
77.
Gold is also 77. Okay, great. Purple equals gold. So what is purple now?
77.
Okay, a lot of 77s. Purple 77, indigo still 4, gold is 77, silver is 77. Now indigo equals purple. So what does indigo become now?
77.
So we end up with that all 4 colors end up as 77. Any questions about that? Yeah.
So after, let's say you added another line after 15.
Yeah.
And so then, so if then, would it be reading it as 77, as indigo is not less than purple anymore? Is it equal?
Oh, so like if I say P, I don't know, 1000, you're saying, okay, so Sam has a really good question. So if I understand your question correctly, at this point, indigo is less than purple, right?
Yeah.
But by the time we get to, let's say, line 16, indigo is no longer less than purple because indigo is actually equal to purple. So Sam's question is, what happens on line 16? Is that your question?
Yeah.
Yeah, that's an awesome question. My answer is the line 16 does indeed still get run because the way Ruby works is that once this condition is true, no matter if that condition might change later within that if statement, it doesn't matter. Ruby is like, full steam ahead, I'm executing everything within this conditional. So line 16 still gets run. That's an awesome, awesome question. In fact, I'm going to put this, make a note to put this in my curriculum to point that out. Hold on. Sorry, give me a second. Okay, let's move on. Okay, if gold is equal to purple, and note the double equals, right? So is gold equal to purple at this point? It is. All the colors are 77. So gold equals gold plus 1. So what happens to gold? It's 78. So now that's gold is the outlier. Any questions about that? Okay. If silver is equal to gold, is silver equal to gold? No, not at this point. So I feel like you all got the hang of how Ruby reads 1 line at a time and executes 1 line at a time. That's the key to understanding all of this. Because at one point in time, silver was equal to gold. But by the time we got to this line, it is no longer equal to gold. Okay, brings us to our last conditional, our last if statement. If indigo is equal to gold, is indigo equal to gold? No. So we remain with this. So if you want to double check, let's print out to the terminal purple, gold, indigo, and silver. And we'll see that they're all 77 except for gold, which is 78. So our prediction is accurate. Does that make sense? Cool. Okay, one last quick concept before we take a break. You've probably all noticed that in all my examples of conditionals, this code, the code within, but in between the if and the and, is indented, right? I happen to indent it 2 spaces. That's sort of the common practice in Ruby. In other languages, people might use 4 spaces, but everything within the condition, within the ifs, between the if and the and, is indented to the right. Would anyone want to take a stab as to why I do that? Doesn't need to happen. What would happen if I didn't do that? Would this code still run? So it's just arbitrary, so there's no real way to really guess at this. But the answer is that in Ruby, the code will still run. These indentations are purely aesthetic, and my code will run just the same even if I don't indent.
So it makes it more readable, though.
Yeah, so the answer to my question is, so why do I indent it? The answer is because it's easier for the human to read. So we'll just demonstrate. If I run it, it works just as well. Who said that? I didn't see who it was. Joseph? Kale? Who said it was more readable? You did? Awesome. So Kale said, yeah, it's easier to read this code if I indent that. Awesome. So I encourage you as well, whenever you're writing if statements, that everything in between the if and the and, if you indent it, you're making life easier for the next developer who's going to be reading your code. Does it make sense to you why it's more readable? We're going to get into more complex examples, and then you're for sure going to understand why it's more readable, because you're going to it'll be hard to live without the indentation. Now, it should be noted that there are languages, like Python, for example, where you must indent. And if you don't indent, it won't work. But Ruby happens to not be like that. Ruby indentation is not necessary, but it's a nice favor to the next developer who will look at your code. And sometimes that next developer might be you, right? 6 months from now. You have to come back to your own code and be like, what on earth did I write here? So you could do yourself a favor by indenting in the first place. Any questions? Because you know there's a break. Okay, so let's take a 10-minute break, and let's start up again at 7:18. Okay, so I have some new code up on the screen that has a new keyword that we have not yet introduced in this class called else. So take a stab as to what you think will happen if we run this code. Let's take a look at it for a moment, and what do you think will happen?
Rupert is greater.
Print one.
What's that?
Oh, print two, actually.
Say it'll either. So if Rupert is greater than 10,
Mm-hmm.
it would print 1.
Mhm.
Otherwise, it would print 2.
Mm-hmm. So in this case, is Rupert greater than 10?
No.
So we'll print 2.
Right.
So, yeah, Crystal is correct. So it sort of reads like English. Basically, if this condition is true, then do this. Else, meaning otherwise, do that. So if Rupert is greater than 10, then we'll print 1 to the terminal. Else, meaning otherwise, we'll print 2 to the terminal. So since in this case Rupert is not greater than 10, because it's only 7, we end up printing 2 to the terminal. If we'd flip this around and say if Rupert is less than 10, then it will print 1. But it does just one or the other. It either prints 1 or it prints 2. It'll never do both. Yeah.
Would Ruby stop at 3 and not read 5
Yeah.
and 6?
Yeah, good question. So Josh is asking, how does Ruby process this? So yeah, let's go through this line by line. In this example, it processes line 1, processes line 2 to check the condition. Since in this case Rupert is less than 10, it processes line 3. It processes line 4 to check the else, but since the else does not apply, it skips line 5 and then concludes with the end. Totally skips it. If we had a division error in here, wouldn't get triggered because Ruby just skips over that line entirely. And similarly, if I flip this, that if Rupert is greater than 10, then we'd skip line 3 and instead run line 5. Yep, so they're the same concept of skipping, but now we're introducing like a fork in the road, right? Either do this or do that, just one. Any questions? Okay. Here we have a more complex example. Yikes. A much more complex example. And I guess let's just walk through this together, and I'll ask you to help me out. So let's keep track of what Xavier and Zelda is at any given time. So obviously on lines 1 and 2, Xavier starts out as -5, Zelda starts out as 10, okay? So help me out on line 4. If Xavier is less than Zelda, is Xavier less than Zelda?
Yes.
So does line 5 get run? Yes. So Zelda is now the same as Xavier, so that means Zelda is -5, and Xavier's also remains -5. Let's make room. And line 6 also gets run. So Xavier is now +5. So Zelda is -5, and Xavier is 5. Questions about that? Does line 7 get run?
Yes.
It does, because that's the actual else, so Ruby does hit that. What about line 8? Does line 8 get run? Does not. Does line 9 get run? Nope. Does line 10 get run?
Yes.
Yeah. Any questions about that? So we skipped over lines 8 and 9. Because with an if-else, it's always we do one or the other. We always do one or the other. We never do 0 and we never do both. It's always going to be this or that. Okay. Line 11 is blank. Yeah, we run that. Okay. If Xavier is equal to Zelda, so we run that. Is Xavier equal to Zelda? It is not, because Zelda is -5, Xavier is +5. So we skip over lines 13 and 14. We run line 15. Do we run line 16? Yes. Because if we didn't run this fork in the road, that means we have to run the other one. So else, if I were to ask you in English, what does this else mean? The answer is, this else means that Xavier is not equal to Zelda. That's sort of the logical equivalent. So on line 12, we say, if Xavier is Zelda, do this. Else, meaning the other possibility, which is that Xavier is not equal to Zelda, then do that. And personally, a lot of programmers do not do this. I've never seen it brought down or published as a best practice, but I think it should be. If I ever have an else in my code, I always put a comment and I spell out what it means to save the next programmer the headache of like doing that back, the logic of flipping it. Right? They have to think in their heads, okay, well, I told Xavier is Zelda, so what else if it's not? If Xavier is not Zelda. So I just spell it out. I say, if Xavier is not Zelda. No one has ever done me that favor by putting that in their code, but I at least do that for others. Can the other developer figure it out without my comment? Yes, but they have to think a little bit. And if I can save them from thinking, then that's cool. Okay, so does line 16 get run?
Yes.
It does, because Xavier is not Zelda. Xavier, again, is Zelda's -5 and Xavier is 5. So Zelda now is what?
5.
It's 5. Sorry for bringing in negative numbers here. That's annoying. I know. Zelda is now 5. Xavier is still 5. And what is Xavier now? Xavier is now -5, right. So Zelda, still 5, but now Xavier becomes -5. Do we run line 18? Yeah. Okay, we're almost done. Line 19 is blank, yeah, we run it. Line 20, if Xavier is greater than Zelda, do we run that line? What about the line itself? We run the line itself. Is Xavier greater than Zelda? No. It's 10 less than Zelda, right? So do we run lines 21, 22, and 23? We do not. Ruby skips over them. We run line 24. How would you say line 24 in English? It's a little tricky. If Xavier is not greater than Zelda. Great. Do we run line 25? So Zelda is now 2. Xavier is still -5. Line 26, do we run that? We do, because we're still in this else condition. So if we run line 25, it means we also run line 26. Zelda is still 2, and what is Xavier now? It's -4, yeah. Again, sorry about the negative number business. But yeah, when you add 1 to a negative number, it just decreases like that. Okay, and we run line 27 because that is the end. Questions about this? Obviously, this is a more complete example. Yeah?
Could you go back up to the initial first part? So when we're reading the first conditional, if Xavier is less than Zelda, which it is, right?
Yeah.
So then we go to line 5.
Yeah.
You had said, I guess, in right and Ruby are the values that get processed first, and left is where the int goes. So would it be Xavier would then be, it would be 10 instead of -5, but then I guess that would make it the whole conditional meaningless because Xavier would no longer be less than Zelda.
So you're saying at this point,
Why wouldn't it change to 10 instead of -5 with those, if you're going from right to left?
okay, so if we're going to right to left, it means we first process whatever is to the right of the equal sign, right? So so let's process Xavier. If we're Ruby, what is Xavier at this point? Xavier is -5, right? We then take -5 and say, okay, we're going to assign that also to Zelda. So Zelda is now also a nickname for -5. Does that make sense? Yeah.
Okay, so it is going right to left.
Yeah, we're saying Xavier, again, it's just a nickname. So Xavier is basically our nickname for -5. So it's as if we had said Zelda equals -5. So we actually haven't changed Xavier in that line. We just referred to it. And now Zelda becomes -5 as well. We're basically saying Zelda should now be whatever Xavier is. Yeah, other questions? No? Okay, this is, tricky stuff. So okay, I have an exercise. So I'm slacking it now in the general channel. And the exercise here is to keep track of the variables. So the variables here, not referring to any popular TV show from the 70s. We have 2 variables, Greg and Marcia. So use your comments throughout to indicate on every significant line what Greg and Marcia are as of that line. And then save it and Slack it to me. So let's look at this example. And once again, you'll help me out. So we start out with Greg being 0, Marcia being 1. Okay. We come to line 4. if Greg is equal to Marcia. Is Greg equal to Marcia? No. So does line 5 get run? Okay, good. Does line 6 get run? Does line 7 get run? It does. Because this else is the equivalent of saying what in English?
Greg isn't equal to Marcia?
Yeah, if Greg isn't equal to Marcia. Right? Either Greg is equal to Marcia, else, meaning if it's not the case, meaning Greg isn't equal to Marcia, then we run line 7. So on line 7, what happens to Marcia? Marcia becomes 0 because Marcia is Marcia times Greg, which is the equivalent of saying Marcia is 1 times 0, which is 0. So Marcia is 0 and Greg is 0. And this is where it gets tricky. Well, I don't know if it's tricky, but it's sort of like a trick question. Okay, line 10. If Greg is less than Marcia, is Greg less than Marcia?
No, they're equal.
No, they're equal. So do lines 11 and 12 get run? No. What is line 13? What does the else mean in English?
They aren't equal.
Otherwise.
Otherwise, but what? Spell it out. Otherwise what?
Greater than or equal to Marcia.
Yeah. If Greg, different ways to say it. If Greg is not less than Marcia, your way is also valid. So Greg is not less than Marcia, because they're the same. So Greg is not less than Marcia. So line 14 gets run, right? So Marcia is 0, right? And Greg is 2. So if Greg is greater than Marcia, is Greg greater than Marcia?
Yes.
It is. So we have to run all this gobbledygook. So notice this is something you haven't seen before in this class anyway.
I don't believe it.
What?
If Greg is greater than Marcia, nothing happens.
Oh, I'm sorry. Yes, I stand corrected. Yes, if Greg is greater than Marcia, correct. Yep. I was wondering as I'm saying this, like I was pretty sure when I made this exercise that I wouldn't have to run that gobbledygook. Yep. Good call, thank you. So if Greg is greater than Marcia, Greg is greater than Marcia, right? Because Greg is 2 and Marcia is 0. So this is something you haven't seen before. There's actually no code between my if and my else, and that's perfectly valid. We just basically say do nothing. If Greg is greater than Marcia, then do nothing. Otherwise, do all this. But we never hit these lines, right? Ruby skips right over that whole thing. And thank goodness, because who wants to do that? That's why I was like, wow, I was pretty sure no, I don't have to do that. So this was the tricky thing I threw in here was the fact that there's no code in between the if and the else, but that's okay. It means do nothing. How would you say this else in English? If Greg is not greater than Marcia. But that's not the case. Greg is greater than Marcia. So we just do nothing. And this never gets run. It gets skipped right over. Does that make sense? Even if it makes sense, are there any questions about that? Okay. I like questions. Okay. The next exercise, I think, is pretty hard, but you'll let me know. And this is a new exercise type. This is where I ask you to explain to me in English what this code is doing. So just put a comment on the top or the bottom, save it and Slack it to me. I've never tried this exercise on someone before, so it could be it's impossible, or it could be it's easy. I don't even know. You'll be the judge. If it's hard, don't be frustrated, or you can be frustrated, but don't think down on yourself. It might be really hard, huh?
No.
I'll put it up here. Yes, but what I end up doing is I just put a bunch of stuff and I blah, 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 blah. And you could put a comment. It's true I said you put it at the top or bottom, but actually might make more sense to put it on each line or wherever you see fit. And in your English, explain like what is going on in real life. What is this code representing in real life? I see. There's some really good responses here. Okay. Really impressed with the responses that I saw. So this is actual real code taken from an e-commerce site that it was my first developer job. It was a site called Doggy Loot, which may or may not still exist. I guess I could find out right now, right? Of course, this is all on tape. Moment of truth. Yeah, it still exists. Okay. So my first developer job after school was, I guess I could bring it back up, was Doggy Loot, which is, at the time that this started, it was the time that Groupon was just gaining traction. Since then, Groupon is not what it once was, but at the time, everyone wanted to be Groupon. Groupon was like the biggest tech thing in Chicago. So a bunch of people got together and started Doggy Loot, which was a Groupon clone, basically like a deal a day for dog-related products. I don't work there anymore, so this is not an advertisement for Doggy Loot, but, ooh, I didn't do that. So when yeah, and I didn't do, oh, no, yeah, no, okay, that's not bad. Okay, it looks nothing like when I worked there. This is years ago. So the code that you saw there was pretty much the same exact code that really existed in the website. So this is real stuff. Basically, it represents, not that. It represents somebody buying a product. And at Doggy Loot, at the time anyway, we offered store credit. You can earn credit by referring a friend and I guess if you return something, maybe you get store credit. So there's basically two paths that someone might have. Someone might have, everyone has a certain amount of store credit. Your store credit might be 0, but everyone has a store credit assigned to them, some number. So there's two, in calculating how much a person would owe when they have store credit and how much they would pay with their credit card when they have store credit can really follow two possible paths depending on whether someone has enough store credit to cover the entire purchase, or the alternative where someone has either no store credit or just partial store credit that only covers part of the purchase. And that affects the logic of how we do our calculations when charging them. So in the first example, or in the first part of our condition, if someone has less store credit than the amount they owe. So let's just use real life examples to make it a little easier to understand. So let's imagine that you're buying, I know what example I'm going to use. The best product we've ever sold at Doggy Loot when I was there was you can buy, I think the cost was like $100, but everything on Doggy Loot is like really discounted prices. So you get it for only $50, a session with a dog psychic. And what the psychic specializes in communicating with your deceased pet. And when we put this on the site, I was so excited. I was like, I just want to see how many people buy this. And I think like 4 people bought it. Really low compared to some of the other products we sold. But I mean, I'm just picturing the situation. I'm picturing a scenario like I'm talking to the psychic, and like, please tell me what my deceased Fido is saying. The psychic's like, I hear him. She's saying, bow wow, wow, wow. Like I could have done that. So let's say that you're purchasing that deal. The amount due, you owe $50. Because that's how much the psychic costs. But let's say you have some store credit. But your store credit is, let's say, less than $50. Let's say it's only, okay, good example, $25. So let's walk through this. If your store credit is less than amount due, which is the case in this example, and someone pointed out correctly in their Slack to me that this code actually will throw an error because none of these variables have been defined yet. But this is sort of like taken from like the middle of a greater context of code. So just imagine that we established, I guess we sort of could, I guess, right? We could just establish them here. Amount due is 50, and then store credit is 25, and then it would run. So if the store credit is less than the amount due, then the amount due after spending your credit becomes amount due minus store credit. So it's sort of hard to, at first, perhaps to reason about, but basically we're decreasing amount due by your store credit. So if your amount due is $50 and your store credit is $25, Ruby calculates that immediately as $25. So the amount due is now $25 because you're using $25 of your store credit towards the purchase of $50. So now your amount due is going to be, you only owe on your credit card, you only owe $25 because you're using $25 of your store credit. Does that make sense so far? Now, since you're using your store credit, we have to save that data as well. And you've used all your store credit because you didn't even have enough store credit to make the entire purchase. So you depleted your store credit. Your store credit, we know for a fact, by definition, if your store credit was less than your amount due and you're using as much store credit as you have towards that purchase, then by definition, now your store credit is going to be reduced to $0. Does that make sense? It's tricky. It's trickier to write this. And I have a good story about that too. Questions about this? Okay, now let's do the other scenario where I refer all my friends to Doggy. I just referred 17 people to Doggy. So I have tons of store credit. So I have $1,000 in store credit. And I just want to buy, I don't really believe in the psychic, but I have $1,000 in store credit. I can pretty much buy anything on Doggy. So I'm going to buy that. So in this case, the amount due is still $50, but I've got $1,000 in store credit. So in this case, the other fork in the road of the conditional gets triggered, right? Because if store credit is less than amount due is no longer applicable to our scenario, right? Because our store credit is not less than our amount due. Our store credit is way more than our amount due, right? So the else is what gets triggered. The else can be said in English as
If amount due is not greater than store credit?
Yeah, amount due, and another way to say it, which I'll prefer this way in this scenario, is amount due is either store credit is either equal to or greater than amount due, which is the same thing that you said, just different words. Just easier, I think, in this scenario to think about it that way. So basically, if I have enough store credit to pay for this purchase, maybe I'm using all of it towards the purchase, but I have enough. In that case, we're not going to wipe your store credit down to 0, right? Because you're only using part of your store credit to cover the entire purchase. But we do have to reduce your store credit according to what you're using here. So store credit now needs to be updated to be whatever store credit minus amount due is. Basically, we're reducing your store credit by whatever you're buying. So I'm spending $50 of my Doggy Loot dollars, I think they were called. So now my store credit is now what? $950. I have $950 Doggy Loot dollars. But since I paid for this whole thing in store credit, my amount due is now 0, right? At least on my credit card, right? I reduced my Doggy Loot dollars, but I don't have to pay anything on my credit card. Does that make sense? This is perhaps the first realistic scenario we encountered tonight in like where conditionals are used in real life. Now, in our code, in the real life, like in the Ruby on Rails site, we wouldn't have these variables created there. Basically, all we do is pull from the database and see how much, let's look up this user in the database. Let's see how much he or she is buying now, spending now. Let's see how much he or she has in dog-eat dollars. We pull those and then create the variables out of the database, and then proceed with the remaining code. Yeah?
How are you supposed to do that if we didn't have that information above? You just presented us with that.
Yeah, that's why it's a tricky question. It's just seeing if you can, and that's why this is my first time giving this exercise. I don't know if it's something that people can reason about without seeing that beforehand. The more you see these type of things, the more you get used to these examples. Other questions? Yeah.
So is it possible, because I know APIs are things you can kind of like say embed into a software language that basically pull from things like databases and other functions. So is it possible to create a variable within, say, a Ruby program, and then just have that kind of function as something that pulls from one of those APIs, like for example, maybe store credit pulls from the store credit database or something?
Yeah. So, yeah, good question. So, in a classic, let's say Ruby on Rails site, you wouldn't necessarily. Well, you might. Depends how you set up. It depends how you set everything up. But in the classic site, your Ruby on Rails site can pull straight from the database that's attached to your site. If you set it up in a more complicated way, yes, you can use APIs, but that's for sure beyond the scope. That's a good question. Other questions? Okay. Now this is a good story. When I wasn't the first developer at Doggy. I was the second developer. We only had one at a time. Someone created the site for about 3 months, and then that person left, and I replaced him. And I was an intern actually when I started. And I went straight from intern to lead developer by mere fluke. That's another good story. I'll tell that story now. So we basically worked as part of an organization called Sandbox Industries, which still exists, although they don't do this thing anymore. Basically, they create 10 new startups every year, and give a little seed money to each one, with the understanding that probably only 1 out of 10 will actually go anywhere. And they find the one that gains traction, shut down the other 9, and continue to pour money in that one, hoping that it becomes the next Groupon or Facebook or etc. So every year they'd start 10 new startups. So I actually started as an intern there, working on all the different startups, just sort of as a shared resource. But then they put me on Doggy Loop, which is one of their startups that actually started to gain some traction. They actually had users sign up, and people were actually buying things. And the understanding was that I would just be an intern for a few months. The developer who created this site was a shared resource, and he was moving on to create one of the next startups. And I'd be the intern maintaining this site until they found a lead developer. So after a few months, they found a lead developer, a 19-year-old fellow named Jade from California. And I met Jade. He came in to interview, and he taught me a few things because I was still pretty new. And I was going to move on to some other startup. And I was excited because I like moving around a little bit. And I don't own a dog, so couldn't bring anything home for the family. People are like, why don't you work on like a site that has baby products? Because we all have babies in my family. So so I was excited to move on. And the day came where Jade was supposed to start. It was a Monday, and he was supposedly moving from California with just a backpack. That's like all he owned, and that was cool. And he came Monday, he didn't show up in the office. So I was like, this is weird. The CEO was like, this is weird. The COO was like, this is weird. They told me, so I'm like, what's going on? They said, well, we actually don't know what's going on, but it was really weird. We're trying to get through to Jade. We actually haven't heard from him despite numerous emails in the entire past week. So we don't really know what's going on. So I'm like, okay, whatever. Jade calls him up on Tuesday saying, yeah, I'm coming on Wednesday. And the CEO called him back, and it's like, no, no, you're not. we need clear communication here. If you can't just decide you're coming on Wednesday when the agreed start date was Monday, and we didn't hear from you the whole week beforehand. So then they basically said to me, okay, Jay, we actually like your work, so we decided if you're willing to make you the lead developer. So I called my wife and said, yeah, I'm going to be working on this doggy loot thing for a while. So I was the lead developer, but really the only developer, but I loved having in my email signature lead developer. That felt really good for my ego. But anyway, I took over from the original developer, and I came to this section of and I was already working there for quite a few months until I really sort of read. I mean, when you come onto an existing project, there's like thousands of lines of code that are already pre-written. You don't have the opportunity to just like sit down and like read all the code. Basically, they throw features at you, and you find the appropriate section of code where you write that new feature, and over time you end up seeing all the different parts of code. Came time for me to really dig into some of the store credit stuff, and I came across, let me eliminate this, I came across this code. However, there was one modification, and that is that these two lines were in the opposite order. So let's walk through what happens in this code. Okay? Let's do this together. So let's say, again, this else only gets triggered if the store credit is equal to or greater than the amount due, right? So imagine that someone has $1,000 of doggy loot dollars, and they're going to pay for the whole purchase. What happens? So on line 5, the amount due is $0. That's cool. That makes sense, right? They're going to pay. They don't have to pay anything on their credit card. They're gonna pay for this whole thing with doggy loot dollars, right? Awesome. Now line 6, store credit. Let's reduce their store credit by store credit minus amount due. So let's say I have $1,000 in store credit. What is my store credit after this line? It's unchanged. I still have $1,000 doggy loot dollars. So if I have enough store credit to buy this whole thing, I can buy it and keep my credit. So I saw this and I'm like, this is really funny. Like, when I read this code, it seems like they're not getting a reduction in credit if they can pay for the whole thing. That's really, and I'm reading it over and over. I'm like, it can't be. It can't be. And then I try it, and yes, you can buy stuff with credit and not get a reduction in doggy loot. And that had been in the code for like 6 months. And I was so happy that wasn't me who put that in, but we all make mistakes. Later at Doggy Loot, I did make a mistake in my code that cost the company tens of thousands of dollars, and I apologized to the CEO, and it was all good. Depends on your situation. I was lucky. But this is like, and the first thing I do is I start looking in the database. I'm like, if someone knows about this, if one of the customers actually figures that they don't see the code, but they just notice that they can keep on buying things with credit. And I couldn't find anyone who seemed to be taking advantage of it, but certainly inadvertently, people were buying things without a reduction in credit. So this is the worst kind of error, the worst kind of bug in your code, because you don't get an error message. Everything works, just the logic is wrong. And it's really hard to catch it. And in most cases, this would have been caught by the CEO coming to me and being like, we're doing like, the financials and something's weird here. And then I would look and find it. It happens to be I was just looking at this code and I was like, this seems weird. It can't be doing what I think it's doing. And yeah, logic is tricky. And this person who wrote that code is a very experienced developer, but people make mistakes. I think the main moral of the story is always test your code in real life, right? Test it out on the website, make sure it works. Yeah, but that's a story of what happens when 2 lines of code are out of order. I love that story. Okay, let's take a break, and we're going to start at 8:20. Okay. We're going to move on to the Next concept, which actually isn't too difficult, just one additional layer onto the concept of conditionals. I have a new example up here with a new keyword called else if, which if it was up to me, I would write it with an E over there in like English. But for some reason, the creators of Ruby decided to spell it like that. And you could probably read this. It reads sort of like English. But we're basically grouping 3 conditions together. And here we have Harold is 5. So we're creating the variable called Harold, which is a nickname for 5. We then say if Harold is greater than 5, then print the number 100 to the terminal. Else if Harold is less than 5, print the number 200 to the terminal. Else, if neither of those 2 conditions are true, then print 300 to the terminal. How is it possible that neither of those conditions can be true? How could it be Harold is not greater than 5 and it's not less than 5? If it's equal to 5. So my translation of this else is if Harold is equal to 5. So in this case, when I run this code, what will print out in the terminal? Yeah. So it prints out 300 because it is this else condition that is true. Now, remember how we spoke about when we dealt with if and else, we said we could only go down one of these 2 paths. We never go down 0 of the paths. We never go down both of the paths. We only choose 1 out of 2. When you group 3 or even more conditions this way in one large statement, we only choose one of the paths. So if there are 3 possible paths here, we only choose one of them. It's always just going to be 1. Now, if Harold is, say, 4, then the path that we follow is this one, right? Harold is less than 5. If Harold is 6, the path we follow is this one. But whatever Harold is, only one of these 3 paths are going to be triggered. Questions about this? Yeah.
Why wouldn't, I think I don't understand what else it is.
Mm-hmm.
Why couldn't you just put else twice?
Yeah. So I guess walk me through what your case would be. So what should I have in line 5? Just else? Like just like that?
Would probably be because if you're just having else, then you're just stitching on, like, say, an otherwise, opposed to else if, which allows you to quote, acknowledge this as an otherwise, then create within that function another condition. So it's like, if otherwise, if, then.
Well, I guess Sam, tell me, is this what you had in mind?
Yeah, I just don't understand else.
Yeah. So think of it. Well, let's see. This wouldn't. I don't think we could do this in Ruby, but if we tried this, then this sort of would never ever get run, because it's like if Harold is greater than 5, print 100. Otherwise, print 200. There's never going to be like an otherwise, right? It's either it is or it isn't.
Okay, so you're cannot do that.
Yeah.
If Harold was greater than 5, the other.
Yeah.
Else. If Harold was less than 5, print, and then you can't do else.
We can only have else once at the end, which is basically if none of the above conditions applied, then do this last thing.
So can you do multiple else then?
Yeah, we could do a ton of them.
Okay, so that's the function.
Yeah, so else if is basically used if you have 3 or more possible paths to go down. So with just 2 possible paths, you could get away with if and else. If you have 3, as soon as you hit 3, you're going to need to start using else ifs. You start with an if, and then everything else is else if, else if, else if, and the last thing is else. Else meaning otherwise, if none of these previous conditions happen, or true, then do this last thing. It's like the catch-all. And we're going to see more and more examples of this. In fact, the next example involves quite a few else ifs. Let me pull it up. Okay, here we have, we're creating a variable Yolanda, which is 10. A lot of possibilities here, and this is tricky right here, and you'll see why. So, let me just read you through it. If Yolanda is less than 5, print 1. Else if Yolanda is greater than 5, print 2. Else if Yolanda is 10, print 3. Else if Yolanda is less than 10, print 4. Else if Yolanda is less than 100, print 5. What's tricky here is that sometimes more than one of these conditions seems to be applicable. So let's walk through this and see what we think Ruby might do. So we know in this example Yolanda is 10, right? If Yolanda is less than 5, is Yolanda less than 5? It is not. So that means we're going to skip line 4, correct? Okay. Else if Yolanda is greater than 5. Is Yolanda greater than 5? Yes. So we're going to run line 6, right? And that's going to print 2 to the terminal. Cool? Here's the tricky question. Line 7. Else if Yolanda is 10. That's true. Yolanda is 10. But do we print 3 to the terminal? Let's do a vote. Who thinks that it prints? Who thinks that it doesn't print? Okay. So since most people said it doesn't print, we're going to go with that. Because that's true. So the key with else ifs is that, like I said before, we always choose just one path. When you have a bunch of conditions together, else if, else if, else if, the way Ruby works is we always just go with one path. How does Ruby decide to go down, and let's just show this, right? It just prints 2. Why does Ruby decide to go down this path? Because Yolanda is greater than 5. Isn't that arbitrary? Why couldn't Ruby instead to print 3 and go with this condition of Yolanda being equal to 10? Because that is also true. In fact, Yolanda is also less than 100. So why did Ruby decide to print 2 as opposed to print 3 or print 5?
Because you found that one first.
Yeah. So since Ruby, the answer is it encountered that one first. And Ruby reads, again, every line top down. Sometimes it skips with if statements, but it always goes top down. So this is the way Ruby reads it. Yolanda is 10, noted. If Yolanda is less than 5, that's not true, so we skip that line. Else if Yolanda is greater than 5, that is true. We print 2, and Ruby says, oh, there's more else ifs here. I can ignore all of that. Because the rule is that we've executed one path. That's all we're going to execute. That's the way it works. Ruby devisers could have made it that Ruby doesn't do that. It might execute all the various paths that are applicable, but it doesn't. Execute one, and then it jumps out of the hole, just skips to the end. Yeah, Crystal, what's your question?
That was pretty much it. I was
Okay.
just asking, does it, like, basically it doesn't matter what would be on line 7 through 12, or does it actually process 7, 9, and 11?
Yeah, that's a brilliant question. So I think the answer is that this is what Ruby does. I'm not 100% sure, but this would be my guess. Ruby processes this line, and I think, so Anna's question is, what about these? Does it process those? And I think the answer is that it skips it. I think Ruby says, there's no point of me processing this. I know I'm never going to follow those because I did the one path. One skips right to the end. Any questions about this? Yeah.
So the general rule is like if there's one conditional, then even if you have else if functions, it's only going to return basically one.
That's exactly right. It always just follows one path. Even as we see here, if more than one path really technically applies, it will follow the first one that applies, and then it's done. Okay. Now, one other thing I want to point out is, if you notice, I actually don't have an else clause at the end. You don't have to have an else. I just have else ifs. So that's another interesting thing to note. You don't have to have an else. You don't have to have else if. I mean, it depends what you're doing. Okay. Well, actually, it's worth going down that rabbit hole a little further. Let's say I did have an else. How would you say this else in English? It's rough, right? Basically, if none of these conditions apply. Is it possible to come up with a number where none of those conditions apply?
Complex number. Well, it's a good idea to have it, though, just in case you screw the top part up, maybe.
Maybe. I can't think of a number. I don't know math, so I don't know complex numbers, but I mean, I don't think I can come up with a number because any number is for sure going to be either less than 5 or greater than 5. And if you'll tell me 5 itself, that's less than 10 and less than 100. So I can't come up with any number that. So that's why I don't have an else there. But if else we're basically saying if somehow we got to this point and none of the previous conditions apply, then we'll do this. Think of it as like the multiple choice test where the last choice is none of the above. That's else. And just like in a multiple choice test, ooh, I like this analogy. Just like in a multiple choice test, you can only choose, in most of them anyway, just one answer. Same applies by if statements. Just one answer. Okay. Now, let me throw everything on its head. I'm going to modify this code to this. I'm going to break up the if statements to this. So it's the same as before, the same conditions. However, instead of putting it all together in one if statement with else ifs, I've broken it up into 5 independent if statements. What will happen? So let's walk through it. So Yolanda's 10. If Yolanda is less than 5, is it less than 5? No. So we're going to skip 4, right? So Ruby reads this. That. I'm going to skip the blank ones for now. That. If Yolanda is greater than 5, is Yolanda greater than 5?
Yes.
So will it print 2?
Yes.
Okay, here's the key question. If Yolanda is 10, right? Yolanda is 10. Will this line, line 12, will that run?
Yes.
Should we vote? Who thinks yes? Who thinks no? So the answer is yes. And it runs the 4. And similarly, if Yolanda is less than 100, which it is, it prints 5. This is what happens when we break up the statements. They're not tied together as we could only choose one of several paths. Ruby goes through, since we've broken them up into independent if statements, Ruby is not stopped from just plowing its way through all of them and processing all of them. Does that make sense? That is the subtle but crucial difference between the else ifs that are put together and these separated if statements. That is the difference between them. Because one would ask, why do I need else if? Why can't I just do this? The answer is there's a difference. With else if, you're ensuring that only one of the paths are taken. Here, it's possible that multiple of these things might happen. So it's tricky. But it might be hard to believe, but if you program for just a few months and you use conditionals, which you would because all programs do, like this stuff actually becomes second nature, if you could imagine such a thing. Okay. We have an exercise. And this is a prediction exercise. So please do not run the code. You know what? I'm going to, before I slack that out to you, I'm going to the whole time I just got scared that I wasn't. Don't run the code, instead predict what will happen. Yeah, this one you don't have to Slack to me, but actually, if you could just Slack to me if you're done, it's just helpful, so it helps me to know when to move on. Because you can test it out for yourself to see what happens. So. Okay, so help me walk through this. So at the beginning, we established two variables, right? Ursula and Ulysses. Don't ask me how I come up with my names. Ursula is 46, Ulysses is 64. We come to line 6. If Ursula plus Ulysses is greater than 100, and this is the first time I think we encountered like a mathematical expression within an if statement. But you can do that. If Ursula plus Ulysses is greater than 100, is that the case? How much is Ursula plus Ulysses? 110. 110? 110. Okay. So that's greater than 100. So what line runs next? 7. So x is Ulysses. So we introduced x, right? So what is x? 3. Line 8, Ulysses is 46, right? And what's Ursula? So by the time we're done, Ulysses is 46 and Ursula is 64. What line, here's the key question, what line processes next? Yeah, it jumps to the end. because Ruby knows I don't have to look at any of this because I chose the one path. It's always going to be one path. I executed a path. That means I'm done with this whole if statement. And it jumps to the end. So when we print out Ursula and Ulysses, we'll get 64 and 46. Any questions about this? Yeah?
I know that the function that it ended up running was basically the same one the other day where he taught us if we wanted to say have two variables switch values that you would use the third.
Yeah, this is using that same trick of swapping. Yep, that's what this is.
So is that like a very common kind of coding strategy?
It is a common coding strategy. There are actually languages that have shortcuts for doing that, but Ruby does not. So in Ruby, that's a very common technique. No, it's not super common that you decide just to swap variables, but if you were to do it, that is the go-to technique. Any other questions? Yeah?
So it's because they're else if form is why you stop at the, you know, you do it at the 13.
Yeah, so since we know, so basically what we're presenting here is 4 possible paths that we can go down. Either if or else if or else if or else. 4 possible paths. Since the rule is in Ruby, and I think every programming language, that when you have all these conditions wrapped up in one conditional statement, we only go down one path. As soon as we go down one path, Ruby just skips to the end of the conditional because it knows it doesn't need to look at the other paths. As soon as it executes one, it's done. Again, even if technically those other conditions might be true, Ruby still doesn't execute them because the rule is you just follow one path. Okay. Any other questions? Okay. Whew. Next part is sort of mind-bending, which is perfect for the last segment of a late-night class. But we'll try. Okay. There's a lot going on here, but what I'd like to introduce is something called nested if statements, which is a fancy way of saying that you can have an if statement within another if statement. Forget why you want to do that at this point. Let's just see what happens when you do that. Well, I guess let's see if you can predict what happens. So we have a variable QWERTY, which is a nickname for the number 1001. What line processes next? 3. If QWERTY is less than 5, is QWERTY less than 5? No. So what line processes next? Okay, I'm hearing a bunch of line 11s. Does anyone think it's not line 11? Because there is another if statement that starts within there. 8? Some people say 8. Some people say 11. Yeah, those are both very good possibilities. But the answer is that it follows that the next one it processes is 11. The reason for that is that Ruby, within this inner if, Ruby looks at this as one block because it starts within this if. And since QWERTY is less than 5, since QWERTY is not less than 5, anything between if and the next, I have to be careful with my words here. The way, let me rephrase this. The way Ruby knows this is one block is because it starts as an if within this if and also has an end that ends this if statement. Therefore, it's considered to be all contained within this if and this else. And therefore, that entire block of code gets skipped. Does that make sense? Yeah.
Yeah, now on the other hand, say we had if QWERTY is greater than 5, the first conditional, so then it would continue to run.
Well, we'll see that in the next. So we have another nested if statement here. So we can see that. We'll encounter that here. Is that basically what you're getting at? Okay. Now, the fact that I indented this makes this easier to visualize as being contained within that first if and the else on line 11. Although it would work even without the indentation. Imagine if you saw this. I can't do it in one shortcut in this website. I'll come back to this. But you'll see if I unindent it, it's really hard to follow the logic. I mean, even with this, it's hard to follow the logic. But it's even harder if I remove the indentation. Again, Ruby knows that this is one unit because there's an if and an end. And it knows that basically, let me phrase it even better. Ruby matches every end with the previous if that it finds. So when Ruby sees the end on line 10, it looks for the immediately previous if, which is on line 4. And that's how Ruby knows this is one block. Yeah?
So is this like considered nesting? Or?
This is what I call nested if statements. We nest this if statement within a different one. Yeah. I think it's a programming term. I don't know if nested is used in other contexts. Let's walk through the rest of the example, and we'll start again from the top. This is tricky, especially at almost 9 o'clock p.m. Else. Okay, so this is the next line of code that gets triggered. Else, if, how do you say this in English? If QWERTY, right, or is greater or equal even, right? Not greater than 5, not less than 5. Or could be equal or greater than 5. So this is the case. So what's the next line that gets triggered? 12. We move on. If QWERTY is 1,000, is QWERTY 1,000? No, it's close. So what's the next line that gets triggered? 14.
It's hard to see.
Yeah, I think I'll have to reduce the font to get it all in there. Can people still see this?
Yeah.
Okay. Else if QWERTY greater than 1. Is QWERTY greater than 1? It is. So what's the next line that gets triggered? 15. So that, what does line 15 do? Yeah, prints back to the terminal. What's the next line that gets run?
18.
Good. So we could jump to the end of this inner if statement. So 18. And then what's the next line that gets run? 19. So what happens when you run this program? We'll print out 5, that's correct. So there's 19 lines of code here, but Ruby only ends up processing, 1, 2, I'm going to skip the blank lines, 3, 4, 5, 6, 7, the minority of the lines of code. Okay, this is tricky. Again, how does Ruby know what to consider the inner if statements and what the outer if statements? Again, my indentation makes it easy for the humans to visualize, but Ruby is not aware of that. So Ruby knows it by pairing together every if and end that are close to each other within immediate proximity. That's a terrible way of saying it, but basically, it finds an if. It really starts with the end first. Looks for. I can't tell you the exact steps that Ruby processes it, but basically, in logic, Ruby says, okay, here's an end. This is grouped together with the immediately preceding if, and that's one unit. Same thing here. And since these have already been determined to be their own units, then that must mean that this if, else, and end on lines 1, 11, and 19 are their own unit. I feel like I could explain this better, but questions? Or is this too confusing to even ask a question? Is this clear? Okay. I'm finding myself trying to find the right words for it. I feel like I could work on that. Okay. But now to make my other point before abundantly clear, if I removed indentation and asked you to do this exercise, it would be really hard to figure out what's going on, right? It's not impossible. But it's tricky. And you can actually have if statements within if statements within if statements. You could go to infinity. It's really hard to read code like that, and therefore it's best practice not to do that, if possible. In fact, even nested if statements, even just one level deep like this, is also best practice to avoid it, just for the sake of the next programmer who has to look at this code. It's hard to reason about. Sometimes it's unavoidable, but it exists. Phew, who's ready for an exercise on this? I hear the creaking of the chairs. Okay. Good luck. Because if you thought this one was complicated. So here's another prediction. So don't run the code. Instead, predict what will happen. Again, I encourage you to use the comment signs to help you reason about it and figure out which lines Ruby actually executes. Oh my gosh. How did I even make this? Okay, let's go through this one. And I have good news and I have better news. The good news is that you'll never see code like this in real life. The better news is that if you could actually handle this code, that means you're equipped to handle all the conditionals you'll ever see. Because if you can handle this, and this is just ridiculous. Yeah, so let's walk through it. So we're starting out with 5 variables, v, w, x, y, and z, that are 1, 2, 3, 4, 5 respectively. Okay, let's do it. Now this is new. This is the first time you haven't really seen a variable referenced in the conditional, but that's okay. If 2 is greater than 3, you don't have to be great at math to know that 2 is not greater than 3. I'm not going to take a vote on this one. So 2 is not greater than 3. We do read that line. What line gets processed next? 18. Cool. How did you know that? You're right, but how did you know that?
Because the first condition they specified wasn't satisfied, so then else just specifies a new condition which will start to values.
Yeah. And the easy way to I did you a favor and I actually indented everything properly. So you could just visually see, okay, regarding this vertical, with the code that actually touches the margin. We just jumped down to the next section, which does. So all code lines 10 through 17 are completely skipped over. Any questions about that? Okay, what line processes, oh, so else if, does 2 equal 2? Yes. So what line processes next? 19, great. So 19 overrides x. X before was something else, was 3. X is 70. Oh man, I don't feel like writing all those variables. Okay, x is 70. The rest are unchanged. Okay, if 2 is greater, sorry, what line is, I gave it away. Okay, this line is next, right? Line 20 is next. Anyone disagree with that? Okay. If 2 is greater than 1, is 2 greater than 1? What line process is next? 21. Awesome. So now x is 70, y is 80. The rest are unchanged. What line process is next?
25.
Well, before 25. Well, no, you're
22.
24, I would say, right? We close out the end. I mean, technically, I guess Ruby does look at 22 and says, oh, else, like, okay, we're moving on to the next path. Let me skip. I see we're at the next path, but let's skip to the end. Okay, what line process is next? 25. If x is less than 100, is x less than 100? It is, because x is 70. So what line process is next? 26. Ooh, w is 8. What line process is next? 27. If z is 30, is z 30? No. So what line process is next? Else 29. So we skip over 28. What line process is next? Yeah, how would you say 29 in English? Else, what does else mean? How would you say this line, what does this else represent? Else, what's, yeah, z is not equal to 30. So z is not 30, so we move on to line 30. Y is 14. So now we're at w is 8, x is 70, y is 14. What line process is next? 31. If w is greater than 10, is w greater than 10? It's not. So what line process is next? 33 sounds about right. And then what? What's the next line? 34. What's the next line? 35. What's the next line? So where does this else going back now? Let's translate this else. What does this else represent? Else what? Yeah, let's say it louder. Is if x is greater or equal to 100. Does everyone agree with that? So this else goes back, and you could follow the vertical line to this, right? If x is less than 100, else, if x is greater or equal to 100, what line process is next? 45. We close out because we skip over that. We already took our path. What line process is next? 46. What does this also represent? Let's go all the way back. Woo! Well, it's basically one of those none of the above, right? If it's not the case that 2 is greater than 3 or 2 is equal to 2, if none of the above is true, then, well, it's not true that none of this is hard to say. It's not true that none of the above is true, because 2 equals 2 is true. So we skip over this else, and we go to the end. So that leaves us with that. So v is 1. So v and z are actually unchanged, and then w, x, and y become 870 and 14 respectively. Any questions about that? Yeah, you'll never see this in real life. Okay. So we actually made more progress on our hunt against Kazakhstan. And we were able to hack more of the source code from their website. So if you go back to the website for QCH, Kazakhstan Central Headquarters, and I'll Slack that to you. And it might take a second to load because it goes to sleep if no one. Whatever. Okay. Now you see on the top there's this thing called phishing. So you click on that. People know what phishing is. Phishing is when you get those Nigerian prince emails saying that this may surprise you, but you get $80 million because of some interesting reason. Just pay us $2,000 to get your $8 million. I'm really, really embarrassed to say that about 10 years ago, before I was as technical as I am today, I didn't actually go all the way through, but I got my first such email. I won some UK lottery. And I actually was so excited. And I told my wife, and she was so not excited. She was like, there's no way you won. Did you buy a ticket? I'm like, no, but it says I won. I'm so embarrassed. And that is on tape besides. Okay. So, anyway, Kazakhstan, one of the dangerous things they do to try to obtain secure classified information from other people is by sending phishing emails. And you, as someone who can operate the QCH, you can actually send this email out described here to 1 million people by clicking that button. Don't click that button. Did anyone click that button?
No.
Don't do it. It's going to send 1 million people an email. Okay. Now, you can take your time whenever to read the phishing email that goes out. But you can also destroy phishing operations by pressing the next button. Only do this if we're about to be caught. So the terminal actually allows us to destroy it. It's a last resort. But to do so, you have to enter your agent name. And that you obtained from last exercise. If you forgot it or don't have it, then I will give you one you can work with. I'll Slack it on general. Or you can use your own. Now, when you put in your agent name and try to destroy the phishing terminal, you'll be confronted with a couple exercises. And there's no way to solve the exercises except for the fact that we hacked the source code for this website. So coming your way in general is the source code behind the code that destroys the phishing terminal. I just Slacked it to you. It's this. And before you proceed, I'm just going to tell you one thing about the second exercise. The second exercise is devilishly hard. And it's really not hard because of any programming stuff. It could be you totally understand these concepts cold, but it also involves a puzzle. So as you do it, you also have to be solving a puzzle besides. So some of you may find that fun. Some of you may find that frustrating. For those of you that find it frustrating, at the very least, as you do that second exercise, as you try, sort of doesn't make sense what I'm saying until you see it, but as you try to work through it, predict what will happen next with each action you do. Even if you don't get to the end, even if you don't solve the puzzle, try to predict what each of your actions will do by reading the source code. And just raise your hand as soon as you're terribly stuck. We probably will not, so just giving you a heads up, we're going to let this go till 9:30, and then we'll demo it first thing tomorrow. So if some of you want to continue to work on it tonight still, you can. I won't give it away tonight.